So we're going to look at vectors and matrices in the form of we're going to do the past paper as and at the same time learn the content, right? So let's get going. All right, now, so vectors and matrices is this branch of mathematics that essentially deals with multiple variables at a time in most cases. Well, all cases, we deal with multiple variables. And then normally at this level, we deal with two variables, okay? So let's look at the first question here, question A. Question A reads, A and B are a 2 by 2 matrix such that A is 1, 2, 2, 3, 2, 5. All right, so in your mind right now, you might be asking, what the heck do you mean by a 2 by 2 matrix? All right? And that leads to the word order of a matrix. If I ask you, Trisha, what's the order of a particular matrix? What I'm asking you is, how many rows by how many columns does the matrix have? All right. So by saying that this matrix is a 2 by 2 matrix, what I'm saying is that this matrix has
two rows and two columns.
And we always talk about the rows first before we talk about the columns. All right. Cool.
Yeah.
So a 2 by 2.
Yeah.
So if it's 2 by 2, it got 2 rows, 1, 2, and 2 columns. 1, 2. Capish?
And
now, B is also a, what's the order of B?
Also a 2 by 2.
2 by 2. What does a 2 by 2 mean?
2 rows and 2 columns.
Okay. What's the order of this matrix?
Rows. It's 5.
Hold on, I'm gonna do it. Sorry, let's go. Yeah, what's the order of that matrix?
Two rows, 3 columns. A column, rows go across. 2 rows and 3 columns.
Think about mine. What you say? You must then build out some bring column from left to right.
2 columns and 3 rows.
Okay, what's the order of the matrix now? Let's start again.
So it's, where's the come first? Column come first?
Row come first.
Okay, so it's 2 columns and 3 rows and 2 columns.
Okay.
3 rows, 2 columns.
Okay, all right, good. So we call this a 3 by 2 matrix. All right.
Hold on. 3 rows. Let me see something.
It's a 3 by 2. It's a 3 by 2, not a 2 by 3. Again.
Okay, because the row, it's a row come first, so it's 3 by 2. Right. Okay.
All right, now we said that a matrix in math is an array of numbers. All right. Again, a matrix in math is an array of numbers. Array mean a set of numbers representing some specific data sets. Cool?
Okay.
So, in other words, I'm going to remove one of these because at this level we only work with 2 by 2s. Orders up to 2 by 2. We don't go any further than that. All right. Now, if I say to you, Trisha, that, and just pay close attention here, in a cricket match, right? 2 teams are playing. Okay. So here's your data. I'm going to draw some columns here. Cricket match. All right, so data. So this is Taki, and this is Geisel. G for Geisel, all right?
Yeah.
So Taki win 1 match and lost none. Geisel won 3 That makes sense. That makes sense for that. Taki won 1 and lost 4. All right. Guys, they'll won. So they lose 4. If they lose 4, they win 1 and lose 4 or 5 match play. So if they win 1 or 4, they win. If they lose 4 or 5, therefore they win. All right. So guys, they'll won 4 and lost 1. All right. So this is the win. This is the lose column. Capish?
Yeah.
No. Point standing. Next array. Points. If you win, you get win. You get 1 point. 1 point. And if you lose, so we're saying, based on the data set we have here, we have a match fixation of data, right? So we say the data set Taki, Geisel, T for Taki, G for Geisel. Win column, Taki win 1, Geisel win 4. Lose column, Taki lose 4, Geisel win 1. Cool? Now, points. If you win, you get 5 points. And if you lose, you get 0 points. Understand the data?
Yeah.
All right, good. Now, the question is, based on the data set that we have here, if I ask you, how many points does Taki and Geisel have? The question is, how will I arrange? How could I arrange this data such that I will be able to calculate the points seamlessly? All right. So I'm going to repeat the question. If I want to arrange this data such that I can ask, so that you can determine the amount of points that each team will have at the end of the day, what will we do? All right. Ready?
Okay.
If I look at the first data set here, this first data set represents the points that is gained from both teams, all right? Now, I can represent these points as a matrix, an array of numbers, all right? So, I can represent this as 1, 4, 4, 1, all right? What this array is saying to me is that the first row represents Taki's the amount of games Taki's won or lost. Okay. The second row represents the amount of games Geisel has won or lost. Cool. Okay. The first column represents the win points, the amount of game them win, and the second column represents the amount of games that either teams have lost. Understand?
Okay.
All right, so I've extrapolated this data and represented as what we call a matrix. Now, if I ask you, what's the order of this matrix? What would you say?
It's a 2 by 2.
What does the first 2 represent?
2 rows.
2 rows and 2 columns. Now, if you look at the matrix, the rows have a specific identity, right? The rows represents the name of the school, not true?
Yes.
The name of the school and the amount of points the school as the amount of game the win or lose. The column represents the amount of game we win. First column, win. Second column, lose. Capish?
Right.
So you realize that the data are distinctly organized by rows and columns. Right. Now over here, we have another matrix. Another matrix here is with the amount of points. All right? The amount of points here are 5 if you win and 0 if you lose. Good to go?
Yes.
Now, if I ask you, how many points will Taki have and Geisel have at the end of all of these games? Ready?
2 of them together?
Yeah, man. At the end, no, man. More know how much, wanted to represent a matrix that shows how many points will Taki have and how many points will Geisel have. What operation would you do to these two set of data? What is it? Multiplication?
Multiply.
Multiply. Excellent. So we'd multiply these matrix. All right. Now,
because you say if right?
Yeah, man, right. All right. So we say this matrix is a 2 by 2. Okay. And this matrix is a 2 by 2 by. What's the order here? Talk to me.
Right.
What is the order of this matrix? This one over here.
2 row, 2 column, 1 row.
What comes first? Columns are row.
One is 1 by 1. That makes sense. A row.
How many rows?
Row comes first.
Rows come first, right? So
2
rows by
2.
how many columns?
1
by 1. Okay, so it's a 2 by 1. Okay. All right, good. Now the only time we can multiply matrix, Trisha, and remember this is a sort of a crash, but not so crash course. All right. The only time we can multiply matrix is when these two center numbers here match. Okay.
Okay.
So when this is a 2 and it's a 2, you can multiply them. If it's a 1 and it's a 1, you can multiply them. Now, here, these two numbers here, out here, tells us what we will end up with, the order of the matrix that we'll end up with. Okay? So we will end up with a 2 by 1 matrix as our answer. Okay?
Okay.
All right, so let's get going. Now, how we multiply matrix is like this. We multiply row by column. Okay? So, if I want to find the amount of points that Taki will have at the end of the day, I will multiply the first row here by this column. Are you clear there?
The first row.
First row by this column. Okay? So let's go.
Okay.
In the first row, the first entry in the first row, what number is this?
1.
1. And the 1 represented what? Win or losing points?
Win.
Win. So what we're going to multiply?
No winning point for Taki.
We're going to multiply by 0 or the 5?
5.
5. Good. So then let's get going. That will be equal to, let's do the multiplication.
5.
5 is?
5.
5. All right. So 1 times 5. Let me write it out so you can see here. It's 1 times 5. Now we want to multiply this 4. What are we going to multiply the 4 by?
Five.
The 5? How can you multiply the 4 by the 5? Does that 4 represent our winning points? Our winning game?
No.
No, what does it represent?
The 4 represent a lose.
So we're going to multiply by?
Oh, 0.
0. Good. So we would add that to 4 times 0, right?
Okay.
Good. So this is what represents Taki's points. Do we agree with that? Good. Now we want to represent Geisel's data. And so we'll multiply. You tell me, what are we going to do right now?
You're going to multiply the 4 by the 5.
So we're getting 4 by 5. Good. So row by column, 4 by 5. Good.
And then 1 by 0.
Then add 1 by 0. That's it. Good to go. Plus 1 by 0. Excellent. All right. So what do we get as the answer now? Final answer. Simplify this. First, Taki up here, so what we get? Hello?
5.
5. Geisel?
20.
20. Excellent. Makes sense? All right. So let's see if the data makes sense. We said that based on what we had, a 2 by 2 by a 2 by 1, we would have gotten the result to be a 2 by 1. All right? When we multiply them. Now, if you look at this, did you get a 2 by 1 as the answer?
Yes, sir.
Yes. And what does the rows represent? The first row, what does it represent? In the answer.
The win.
The first row in the answer, what does it represent?
The first, that are the 5 out of 20 you're talking?
Yes. What does the first row represent?
The win for Taki.
Just the win?
The score.
Score. Good. Score for Taki. What does the first row represent for Geisel?
The score for Geisel.
Okay, good. And what does the column represent?
The score of for the game.
Score for the game.
Both Geisel and Taki.
Good. All right. So you see the data, how the data organized?
Yeah, but hold on. Wrap my head around the.
How the row by column concept comes from. All right. In matrix multiplication. Most of the time.
When they are not like the same, you know, so you can multiply it.
When the amount of, let's speak it, when the amount of columns for the first matrix does not match the amount of rows for the second matrix.
For the second, yes.
Then you cannot multiply.
Okay.
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 All right. Represent some distinct data sets. All right. So now my question is, what is BC? Do you know what I'm asking you?
What is BC?
Yeah, what BC represent? What is going on there?
To set up matrices. I don't know if you write it.
No man, just tell me what is when I ask you what is BC, tell me in mathematical language. What am I asking you?
Sir, I don't know.
Don't know? I'm asking you what is B multiplied by C? Okay?
Okay.
Good. So BC. If I ask you what is DF, I'm asking what is D multiplied by F. Okay?
Okay.
All right. So you want to try that for me in your own book? Try that for me, please. Right. Talk me through what you would do with this to find BC. Go ahead.
So, knowing the content, that, as I just said, it's the column on the first matrix is the row on the second matrix, then I can multiply, right?
So, talk about how you would multiply these matrices now.
So, both are the 2 by 2.
So you start.
So I would multiply. I would say that. So I say I have the 2 by 2 over there and a 2 by 2 over the other side. So that means they can multiply, right? So what I'll do now, I'll send times 5.
You say what? Go again.
1 times 5. Plus 2 times 0.
0. Good. And that will give you something right here. So what number is that again? What's the answer? 1 times 5 plus 2 times
5.
5. So the first entry is going to be 5, right?
Right.
All right, good. By the way, what's the order of the answer?
I can't finish it.
What's going to be the order? Yeah, man, you're going to finish it. What's going to be the order of the first niche of the answer?
It's supposed to be 2 by 1.
No, miss. You say any one here?
So 1 by, hold on. It's supposed to be. Yeah. That can ask me.
Yeah, what's going to be the
What
order
the answer supposed to look like?
of the answer? Yeah, what is it going to look like?
Mm-hmm.
2 by 2. I told you, once the column, this column, the amount of columns in the first matrix match the amount of rows in the second matrix, that we know they can multiply. But the amount of rows in the first one by the amount of columns in the second one tells you the order of the answer. Repeat that for me twice.
Okay, the amount of rows in the first one, along with the amount of rows in the second one,
the amount of columns in the second one, and the amount of columns in the second one.
Right. Amount of rows in the first one, along with the amount of columns in the second one,
tells you.
Well, it tells you the order of the operation, the order
of the answer.
The order of the answer.
Good.
The amount of rows in the first one, the amount of column in the second one tells the order
of the answer.
All
right. So this picture is like it's the cricket match and all those things, right? So the first data set represents one person. We get 5 as the answer. Now do the next one.
The next one gonna be, we'll just do 5, 1 times 5, 2, and next one gonna be 3 times 0.
3 times who?
1. 1 times 1.
1 times 1.
And 2 times 2.
Okay, where does that go? Does that go right here or does that go over here? So the answer.
Over that side.
Over here, sir.
Yes.
Good. It's 1 times 1 plus 2 times 2. What do you get as the answer?
5.
Not true? Oh, yeah. Next one.
So the next one gonna be 3 times 0.
No.
Huh?
No.
2. 2 times 5.
No, you do it already. But 2 can't be like 5. Remember, you're matching entries, you know. It's 1 times 5 plus 2 times 0. So first this, the first one over here, so. Second one with the second one in I column.
So I'm gonna say 3 times 0, I said no, you're wrong.
But it's wrong because you're now dealing with a new row.
So 3 times 5?
This is somebody else's data set you're dealing with now. Somebody else's data set you're dealing with. So 3 times 5, right?
Okay.
Let's visualize the example, the concept that we went through earlier. This is 3 times 5 plus what?
3 times 1.
3 times who?
0.
So let's go again. One more time. Multiply the matrix at me.
All right, hold on. All right, this in the next row now, we're doing somebody else thing, right?
Just like we look at it.
We're doing somebody's.
So let's look at it as Taki data, Geisel data, all right?
Okay. So we're gonna have to say now 3 times 5.
You're waiting until you hear me say to confirm. Continue. You're waiting to hear to confirm. Go ahead.
All right. It can be 3 times 0.
No, 3 times 5 plus 4 times 0. All right, so
I just my brain now function.
That's okay. Watch me now. Watch me. You shouldn't skip the step. I told you. All right, watch me. Picture it like this. B, matrix B represents the team and the team's amount of game when they win or lose, right? Matrix C represents the amount of points awarded. So the first row here, so this first column, this first column in matrix C represents the points given. For example, if you're playing cricket in Jamaica, right? If you win one game, you get 5 points. If you lose a game, you get no points, okay? In Jamaica. But we're saying what happens if we're playing the game in China, right? In China, if you win, you get 1 point, and if you lose, you get 2, okay? The follow-up one. The second column represents points in a different country, okay? That is why when you say 1 times 5 plus 2 times 0, that gave you the points for Taki if them play the game in Jamaica and win, okay? The amount of points in Jamaica them get based on the amount of game that they have played. Copy? Then you say 1 times 1 plus 2 times 2 give you 5 because you're trying to find again the amount of points Taki would have gotten if they play the game in China. Understand?
Okay.
That is why Taki points. This is also Taki right there. So this is also Taki's. The first, this row, this entire row represents Taki data set. Cool? And so now you have to say 3 times 5 again plus 4 times 0, which give you guys your data sets. All right, so 3 times 5, 15, plus 4 times 0, 0. So then guys will have 15 points right here. So that's how you go. Hello?
Okay.
And then we have 3 times 1 plus 4 times 2 because you're trying to find what is the points that they would have gotten if the game was played in China. So again, 3 times 1, 3, plus 4 times 2, 8. 3 and 8 is what, 11? That's 11. So that's our answer. That's our answer. All right?
Okay.
That's it. So absorb it. Look at here is, we did multiply B times C, right? I was at 5, 5, 15, 11. All right? Hello? All right, so the question is, what would be CB? CB. If I ask you what is CB, what am I asking you?
So you're saying that because multiplying the C by the B.
Right. Not the B by the C, but the C by the B.
Right.
All right. So try that for me now and tell me what you get as the answer. Let's do that right now.
That's what we did and get the 5 by them.
No, we did B times C and get 5, 5, 15, 11. I'm asking you to do C times B, which means you put C at the front and B at the back.
C at the front and B at the back. Sir?
Yes? You look like you don't understand. You didn't understand something. I'm saying, Trisha, if I said B times C, what am I saying?
If I said B times C, you're saying to multiply the B by the times by the C.
So what
times the C.
Which one at the front? Which one at front and which one at back?
So B there the front and C there the back.
Okay. Now, me ask you what is C times B? Is that the same thing I'm asking you?
Oh, yeah. So now we're going to do the C times the V over here.
Do that now and tell I'm going to get away again.
So do that first.
Yeah, man. Do that, then let me see now. We did BC already. Then I wanted to do CB now.
Okay.
5102. We're multiplying that by 1, 2, 3,
5, 1,
4.
5, 1, 3. Three. BC.
Right answer will be BC. Okay. So again, what we realize here is that when we multiply CB by C times B, the answer was not the same as B times C. And so we say that BC is not the same as CB. But we realize that the correct answer would be BC for this data set. All right. So what we realize is that it's important as to how we do the multiplication. Cool.
Okay.
This is why if you put foolishness in the computer, you take out foolishness. Again, in normal multiplication, we say 2 times 4 is 8. 4 times 2 is 8. Doesn't matter the order. However, in matrix multiplication, the order does matter most of the time. Okay?
Yes, sir.
Now we're progressing the question there. Question AI. Please do that one. Thank you. And the problem says A times B. Remember, it's just that in matrix, they multiply in row times column. So it's A times B. We spoke about the order of the matrix. And that it is important whether you're multiplying B times A versus multiplying A times B. In other words, it's important which one comes first and which one comes after. Okay? So in matrix multiplication, I multiply again, row. What's a row? Row goes from left to right by a column. If you realize here, there are essentially 2 data sets in this matrix. And so we're going to multiply first row by the first column, then first row.
So it's 1 times 5.
Second column. So it's 1 times 5, which is 5,
plus
2 times negative 2, which is negative
2.
5 plus
We
negative
have 2
4. Go ahead.
No, you go ahead. That's one let me say something else.
No, I'm saying you to go ahead.
1 times 5 plus 2 times
you go ahead. Do it. Anyway, so 1 times 5 is 5, plus 2 times negative 2 is negative 4. 5 plus negative 4 is 1. All right?
Hold on, Mr. Dunn. Let me just get that part here. Hold on. It's a 1 times 5, right? Plus the 2 times the negative 2, right? And then what you do again?
Then me add them. That's it. I get 1 as the answer.
Yeah, me get the 1 over here. So the next, so we're moving on to the next sum,
entry.
the next step.
Next entry, right?
Next entry.
1 times negative
which is 2.
Nope. 1 times negative 2. You could do 2 times. You have to keep it in order. So it's row times column, row times column. You have to visualize the data sets as a set of organized data entries. So just like when we did with the cricket match and all of those, you have to visualize them properly and line up. You have to know, say, this represents some specific data set. This represents some specific data set. All right? And you're just trying to find what is the product of whatever this is representing by what's over here. Okay?
Okay. So
1 times 5 plus 2 times negative 2 give 1. 1 times negative 2 plus 2 times 1. So 1 times negative 2 is negative 2 plus 2 times 1 is 2, which is 0. Agreed?
Yes, sir.
Next one. Now we go to the second entry now. We're talking about this other data set. Okay? So this could be clothes. This could be shoes. It's 2 different data sets, okay?
Okay.
So we're done with clothes and we're now going to shoes. Okay? So shoes. 2 times 5. 10 plus 5 times negative 2. Negative 10. So that's 10 plus negative 10 is 0. Got that? 2 times 2, negative 2 is -4, -4. 5 times 1, 5. -4 plus 5 is 1. Do you agree?
That's starting at shows 2 times 5 plus, right, 2 times this 5, then 5 times -4.
So 2, 5 is 10, and 5 times
Yes,
10
the third entry, the third entry is 2 times 5 plus 5 times -2.
Yep, we'll give you 0.
And then the next entry